Hello everyone and welcome to the Pharma Scientist channel. I hope you all are doing good. So today we will look into one of the most important interview series questions and answers which is asked in the pharmaceutical interview, whether you are fresher or whether you are experienced. These questions will definitely be asked in a QC department or in a R&D department or whichever department you go. This is one of the basic questions asked in the pharmaceutical interview question and answers. So we'll see HPLC and GC system suitability parameters part 1. So we will first see what is the system suitability. So here, what is system suitability test? Explain SST parameters in HPLC and GC. So this is the first question they will ask to you, means what is system suitability test. Here I will not just read out all the questions or all the answers. I will try to understand to you the basic. If you understand the basics of each and every questions, you can explain in any way. If the interviewer tricks the questions or asked in some different means, so you can easily explain that questions. So what is system suitability test? So we can understand the test of suitability for the system, means test of suitability of the system, you can tell like this. So what is system? Now you will understand in a very easy way the test of suitability for the system. Explain SST parameters in HPLC or GC. So why SST is done? So we will see in this here. The system suitability test is used to verify that the chromatographic system is suitable for the intended analysis or not. Means that this test is done to check for the intended analysis, means it is the system, whatever system, HPLC, UV, IR, UPLC, GC, whatever system we are using, those systems are suitable for our use or not. Because if we are facing already problem in that, so we cannot use that system. So first we have to check, and that test is called as system suitability test. So this is to ensure that the complete testing system, including instruments, reagents, column, analyst and electronics, is suitable for intended application. Means whatever instrument, reagent, column, analyst, electronics, all are okay. If we are doing okay, then only we can move forward. Otherwise we have to stop there only. There are different system suitability test criteria for organic impurity test and assay test and other test. Organic impurities means OI or RS, and assay means purity testing and other test. If you don't know about this, comment me in the comment section. I will make a detailed video on this. If the system suitability test criterion passes, the test is carried forward, just like I did. And if the system suitability test criterion fails, the test is not continued further. Investigation needs to be done for the reason of failing the test, and analysis needs to be repeated. Means if the system suitability test fails, then we have to stop the test there only, and we need to, it's not that only stop, we need to investigate the test also, why it is failing. So now we will see what are the different SST parameters which are used for different tests like assay or the organic impurities. That is different thing. But first here we will see what are the different tests. So first is precision, resolution, theoretical plate count, tailing factor, signal to noise ratio, or it is also called as S by N, peak to valley ratio. It is also called as P by V ratio. So we will see each and every in detail in this. So first is what is precision? Explain. It is the closeness with which results of replicate, usually analysis of a sample, agree. So you need to understand the meaning of precision. Closeness with which results of replicate, analysis of a sample, agree, usually expressed in terms of percentage RHD. So like replicates like 3, 4, 5, 6, 7, we can give any number of replicates, and the closeness of this, the closeness with results of replicates. Suppose we have our desired criteria 0.85, so how in replicates how close the results is, percentage RHD, how close the percentage RHD with the 0.85. In the 4 readings it will be different, 5 readings it will be different, 6 readings it will be different. That we will see in the coming slides. So this is important to understand here what is precision. So it is expressed in percentage RSD. Percentage RSD is equal to standard deviation into 100 by mean. So it is also written as standard deviation into 100 by mean. The mean of the 5 replicates or 6 replicates or 3 replicates. This is called as percentage RSD. So for SA by HPLC, the maximum permitted relative standard deviation does not exceed the appropriate value given in the below table as per USP and EP. So we will see in the coming slide about the table. So what does it says? For SA, the maximum permitted percentage RSD does not exceed the appropriate value. So whatever the value it has given, it has been given by a logic, by a equation. So it should not permit more than that. B percent means upper limit of an SA minus 100. That is if your SA limit is 98 to 100%. So B percent is 102 minus 100 means 2%. That implies your percentage RSD should not more than 0.85 for 6 injections and 0.73 5 injections. This is very clear. For 6 injection it should be not more than 0.85 and for 5 injection it should not more than 0.73 percentage. This requirement does not apply to test for related substances means RS or OI. This does not apply for that conditions. For related substances that is different. So now in this table you see number of individual requirements 3, 4, 5, 6. I said you number of individual requirement means replicates either 3, 4, 5, 6 whatever replicates, and B means the percentage difference. B means 100 minus 100 102 the upper limit. If it is 2, if it is 2.5, if it is 3 means 2, 2.5, 100, 2.5, 103 percentage. So basically in pharma companies we will give these readings 5 replicates and 6 replicates. So if the limit is 2% 102, it should be 0.73. The 5% RSD of 5 replicates and 6 replicate 0.85. So this is strictly followed whether you are doing by WHO or by ICH or by FDA. Whatever regulatory bodies you are following, it should follow these conditions. This is very mandatory and compulsory. What is resolution? Explain. This is important question, and you should also know as a pharmacist that what is meant by resolution. You should try to understand the basic. Resolution is the ratio of distance of separation of band maxima to their average base width, or the distance between two peak centers of two analyte peaks divided by the average base width of the peaks. I will show you a diagram and I will explain you there. That will be very clear to you. It is the ability of a chromatographic column to separate peaks. It is usually expressed in terms of the separation between two adjacent peaks. Means two peaks are there. This is the base and this is the height. This is the top. So on the basis of this, how it is separated. So let's see in the figure. You see here, this is figure 1 and this is figure 2. So width 1, width 2. We have drawn a structure here, and the it is taken in the basis of the height, half of the height, and here half of the height. So resolution is equal to 2 times of T2 TR2 minus TR1 divided by W1 plus W2. If you can pause the video and you can see the difference of this W1 W2 and the meaning of this height. So you will easily understand the meaning of resolution. TR2 and TR1 are the retention times of two components, right? W and WR2 are corresponding peak widths at the base, as I described earlier. This is as per USP. As per EP, resolution is equal to 1.18 times of R2 minus R1 divided by WH1 plus WH2. This is some or what similar to each other. If you finally calculate the results, it will come almost equal to each other. TR2 are the retention time of two components. WH1 and WR corresponding peak widths at the half height. This I have already explained. baseline resolution achieved at R is equal to 1.5 but more than 2 is desirable. Means this is the basic criteria that resolution should be more than 1.5. On a case to case basis, this is acceptable, that okay, less than 1.5 is also acceptable, resolution 1.5, but resolution more than 2 is very required, because it will depend on the column, on the system, on the environment, that it may fail. 1.5 will not be achieved, then at that time it will be a very problem for us. Therefore resolution more than 2 is a desirable condition. This is all for this video. Thanks for watching. If you do like the video, please do like, comment and share with your friends, and do subscribe to our video. Thank you.